All right, y'all. This one might be a little bit longer. This one's going to be on multiplying polynomials. I'm going to try to keep it under 10 minutes. First thing we need to remember are exponent rules. So remember that exponents denote or mean repeated factors. Repeated factors. So for example, x to the third, this means that x is repeated as a factor 3 times. Factors are things that are multiplied together. Multiplied, ran out of space. What's another example? 2x to the fourth. What is the repeated factor? Well, the 4 is touching the parentheses, so the whole set of parentheses is repeated as a factor multiplied 4 times. And now how do we multiply these? Well, we multiply, we had like terms in the addition and subtraction video. Here we're talking about like factors. So constants multiply each other. So 2 times 2 times 2 times 2 is 16. And then, so we could write 2 to the fourth and then x to the fourth. But 2 to the fourth is 16. Right, so you remember that. So that's the first thing we need to know. The next thing we need to know, recall back to previous math classes where, let's say we multiplied 12 times 25. That's not a times. 12 times 25. Remember that we can break 12 into 10 plus 2 and 25 into 20 plus 5, right? And then we can use an area model to depict this. So instead of, and let me back up one more step, we can also model multiplication as finding the area of a rectangle. Obviously not to scale here, but length times width gives you the area. So area can model multiplication. So here we can break up 12 into a length of 10 and a length of 2, right? 10 plus 2 is 12. And then we can break this side into 20 and 5. And then we can find each of the separate areas. This piece has an area of 10 by 20, which is 200. This piece has an area of 2 by 20, which is 40. This piece has an area of 10 by 5, which is 50. And this piece has an area of 2 by 5, which is 10, and then we add them all up. 10 plus 50 is 60, plus 40 is 100. So 20 plus 40 plus 50 plus 10. 10 plus 50 plus 40 is 100, plus 200 is 300. So 12 times 25 is 300. Now, do I want you doing multiplication like this using an area model? No, but we're going to use this same idea of breaking it apart to do polynomial multiplication. So let's say, for example, you want to multiply x plus 2 and x plus 5. Well, we can denote a side of a rectangle as being broken up into x and 2, right? When we add these two things together, they're not like terms. That's not 2x. X plus 2 does not equal 2x. X plus 2 just means x plus 2. They're apples and oranges. We can't add them together. X plus 5, we can break into an x and a 5. And then we find all the partial areas. This one has an area of x times x, which is x squared. 2 by x, which is 2x. X by 5, which is 5x. And then 5 times 2, which is 10. And now we've got x plus 2 times x plus 5 is equal to x squared plus 2x plus 5x. These are like terms, so we can combine them as 7x, and then plus 10. Easy peasy lemon squeezy. So you're just going to break. Remember that terms are separated by addition and subtraction signs. So we've got two terms here. This is called a bi, as in two, nomial. This is a binomial. This is also a binomial because it's got two terms. This has three terms. It's called a trinomial. Usually when you multiply two binomials, you'll get a trinomial. Sometimes you don't. because sometimes the factors cancel. So I'll do a couple more examples. Let's say it's 2x plus 3 times 2x minus 3. So I typically just make this, and then I say 2x plus 3. The left can go on the left or the top. In fact, I think I usually put it on the left, but it doesn't matter. It doesn't matter which way you do it, right? Because a rectangle that's 2 by 3 has the same volume as a rectangle that's 3 by 2, right? So it doesn't matter which place it goes, as long as you put this on one side and this on the other side. And now we can go ahead and multiply through. 2x times 2x. 2 times 2 is 4. X times x is x squared. 2x times 3, 6x. Negative 3 times 2 is negative 6x. And negative 3 times 3 is negative 9. Notice here that negative 6x plus 6x cancel out. This is not a coincidence. I picked this problem on purpose. When you've got the same two first terms and the same two last terms, but the only difference is the sign here, because one's positive and one's negative, you're always going to get opposite products here, so they're always going to cancel out. So this cancels itself out, and you get 4x squared minus 9. This is called difference of squares. That's a square, perfect square, right? 2x times 2x, that's how we got that, 2x times 2x. And then this one is a perfect square too. So this is called difference, because you're subtracting of squares. And you'll have some practice on that, probably not tonight, but tomorrow night on Delta Math. One more example. X plus 2 squared. This just means x plus 2 times x plus 2, and then you work it the same way. You will start to notice some patterns though, because these numbers are the same and these terms are the same. These two boxes are the same, and since these two boxes are the same, when you add them together you get double one of those boxes. So, and again, I'm telling you kind of a shortcut here. You don't need to know the shortcut. You can always just take the long way if you forget what's going on. But when you square something, right, you get x squared, and you get, this is not, ooh, super, I got to remind you of this. This does not equal x squared plus 2 squared. No, 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 no. Do not make that mistake. Write this down. Do not do this. The squared, you can't distribute the square like that. You've got to go through this whole process, because this is actually 4 multiplications, not just the 2. Okay? So do not do this. Evil, evil algebra, as my high school math teacher would say. Excuse me. But what you can see is you've got x squared plus 2 squared. They do show up. But then you also have that middle term, which is double these two multiplied, because you've got the 2 times x here, and you've got the 2 times x here. That's 2x's, which is 4x. Anyway, if you want to remember that shortcut, you can. Otherwise, just take the long route and do it this way. Message me any questions. What did we get? 8 minutes and 40 seconds. All right.